In this video, we are going to do Chapter 7, Exercise 10. So I have a scan of the textbook assignment over here. And the textbook assignment is actually not asking a lot of you. It's just wants you to fill in the blanks over here. So we're going to talk about what we are filling in. And Chapter 7 is all about tolerances. Tolerances we've touched on. Tolerances is basically telling the manufacturer the limits, the upper limits and the lower limits, or how imperfect it could be. If you say a design should be diameter 2, you need to also specify what is like the upper limit and lower limit. Is it like 2, 2.0, 2.00? Those make a huge difference when it comes to manufacturing. For example, if I say 2 and you don't account for rounding, well, technically, saying that the limits is 2 could be as low as 1.6 and as high as 2.4, because both of those would round down to or up to 2. So 1.6, 2.4 is a huge range. But if I say 2.0, think about how rounding would make that different. 2.0 could be as low as 1.96 and as high as 2. Losing my train of thought. 2.04. So 1.96 to 2.04. Much tighter range of possible acceptable values. And then 2.00, think about how small and how tight that is then. So that's why tolerances are important when you're specifying a project. Now we're going to talk about a different kind of tolerance. So I would have my textbook open. So grab your textbook and open along with me. And we're going to go to Chapter 7. I'll give you the page number in a second. 280, page 280. We are going to talk about geometric tolerances very briefly. Geometric tolerances are basically specifying the imperfection on different geometric planes. So flatness, there's a flatness tolerance. How perfectly flat does it need to be? And it's given by that rectangular rhombus shape. Roundness, is it 100% perfectly round, the same diameter the entire time? Or if you get really close, is there some kind of oval form and or like an ellipse if it's not a perfect circle? That's the roundness tolerance, how round it is. Straight, if the line is perfectly straight, or if there's the slightest distortion. Cylindricity, and then you can see all of them. And the textbook actually does a pretty good job of giving you examples. So I would take 2 minutes and just kind of skim through the pages to really understand. Like on page 282, it gives you a good exaggerated example of what the tolerance showing there, the flatness tolerance. Like if you zoom in, that shows you the flatness tolerance when the part is under like a microscope. Of course, it's exaggerated. Those are really big imperfections if you contributed the one on the right. But you're getting the idea. It's not perfectly flat. Same with the roundness test and all the other tests. Again, take 1 more minute, if that, just kind of skim through, understand what these tolerances are. Okay. Again, I wanted you to just start at 282 and just go through the pages quickly and be like, okay, those are what tolerances are. You have different geometric features and parts, and you want to be able to know what your ranges are within them. It's not just about dimensions anymore. Now it's about geometric tolerances. So now we're going to draw this part, and you'll notice that the part actually doesn't have dimensions. It's just giving you the tolerances. So we're going to make up dimensions that are relatively to scale, but they're not necessarily true. So we'll call this 1, and that's 1, 1, 1, 1, 1, 1, 3. Okay, so we're going to call the outside one 3. And we're going to extrude it 1. Okay, I'm just kind of half talking out loud. And we'll do it in inches because I don't think it's specified, does it? It's probably metric because it's over here. All right, we'll do it in metric. So we're going to do a metric standard part. To be clear, I actually don't really care if it's metric or English. I care more about the tolerances for this one. And the part is actually going to be really easy to draw compared to the other ones. We're not doing an assembly, we're not doing a presentation, we're not doing a side plan set, we're just doing a regular dimension drawing file. Okay, so I'm going to start with it, and I'm going to make a diameter of 3. And I'm going to extrude it 1, and then I'm going to do a new sketch right on top of it, and that's just going to be another circle, diameter 1, extruded 1. Could have done the hole in the middle, right? We'll make that hole, if that's 1, what do you think that is? Good, it's a little bit more than half, so 1, 2, 3, 4, 5, so that's 2.6. It doesn't fully matter. I'm just gonna make it, let's see how 0.6 looks. I think that looks decent. And I'm gonna extrude that down. Of course, you could have did this in the other one, or for both of them really, but I think it's easier this way. All right, and then we gotta do the holes. The holes seem to be like probably the same as this, right? 0.6, and then, I don't know, a little bit left. You can follow my dimensions, but because this isn't exact, as long as it's somewhat ballpark, it's fine. So again, to draw something like that, I always do a construction circle first on a new sketch, and we'll make it 2. And then I just do another one. I don't care about the... Then I do a hole, and now I'm able to pick that point, and we're going to make it 0.6. Let's give an overhead view to see if that's good. That looks decent. And then we do the circular pattern to get all of it. So for feature, select the hole. For rotation axis, choose a middle. And how many do we have? 5? 1, 2, 3, 4, 5. Cool. I don't think it mentioned anything about materials. I don't care. Let's do a file, save as. And we'll just call that Chapter 7, Exercise 10. We're going to then start a new drawing file, metric. Did I do that right? It seemed like too easy. I guess so. Okay. And now we're going to make the sheet size A like we did for most of the year up until we started the presentation files. Nope. See? Force of habit. Now I'm trying to make it paper size C. Get rid of the larger title block, add in the smaller title block, and I'm going to put in my base view, which I'm going to make this my base view. Like that. And then I'm going to do a section view for the other one. Okay, cool. And I'm going to do a section view to get the other side. So when I do a section view, when I hit section, I hit the dot dashed like box, and then I go here, I extend beyond. If you do straight across like this, kind of like what's shown in the textbook page. So look at the textbook real quick. Let's look at this. It has a section view going straight across, and then it looks like that in the end. Let's continue. When I do that over here, oh, it doesn't look like it, because this is a mistake on the textbook. Like if I do a section view, remember this is like my knife cut. I cut here and cut straight across, and then I pull it apart. I don't see that. That's not true. That's not what it looks like. If I want to see this, which I do, the section cut is really starting here, going across to the middle, and then cutting through the middle of another one of these, like an angled section view. This is false. So, those jerks. All right, backspace it, section view, click, go here, go to the middle, and then cut through here. So once you hit the middle of it, extend it to here. And just make sure you're on the same plane and that green dot is always there. Give it a nice little bit off the end. Click, right click, continue. And now I have the true section view that I actually want. Why do I have that middle part? Why do I have the middle? Huh. Yeah, I'm not sure why that middle's there. I don't know. Maybe we'll just try doing it again. Maybe I missed the center. But that should not be there. Okay, let's try it again. Okay, that was weird. I don't know what I did differently last time. Maybe when I watch it again, I'll see. Maybe I missed the middle perfectly or whatever. Okay, anyway, we're good now. So I'm going to, and we have 3 minutes left in this video. I'm just going to add center marks and center lines, and then we'll call for this video. And then the next video won't be 15 minutes, and we'll do the geometric tolerances. So I'm going to do a center mark right here for the big one. And then I'm going to do the circular or centered pattern for this one. So remember, you click on it, you hit the center first, and then you hit all 5. And I always forget if you hit this one again. You do. Right click, create, and then boom, that's created. And then you can do the center line bisector for 1, 2, 3. Okay, I think that's good for this video. I'm going to end it here. And then the next video, we're going to put in these geometric tolerance callouts. We're not going to dimension this regularly. In this one, we're only going to give the annotation for geometric tolerances.